Alright, so welcome back. In the previous page, we mentioned we can convert a document into shingles, a set of shingles, right? And this can be used for help capture the similar patterns of the document's contents. And then based on this conversion results, how can we define similarity scores or similarity metrics among the documents, which will be very interesting. In this page, we can define a very simple and a very straightforward similarity matrix, which is called Jaccard coefficient similarity matrix, or for simple, it is defined as a Jaccard similarity. So Jaccard similarity, this metric is defined based on sets. Given two sets, we can use this Jaccard coefficient similarity matrix to define how similar they are based on their contents or based on these elements. So how to define this Jaccard similarity? It is shown by the equation we show here. So given two sets C1 and C2, there are two sets we get it before by the shingling step of two documents. Given document 1, document 2, we can convert them to two sets, right? And then we can define the similarity scores between them by the Jaccard similarity, as shown here. It is defined by its size of C1 join C2 over the size of C1 union C2. You can follow me, right? So this C1 and join C2 denotes how many common shingles do they contain in the document, and C1 union C2 denotes how large these shingles of both C1 and C2 consider them together, right? And this fraction will define the similarity scores between them. If C1 and C2 they contain exactly the same contents, then their shingle sets will be identical, right? In other words, C1 join C2 will be equal to either C1 or C2, right? At the same time, C1 union C2 will also be equal to either C1 or C2, right? In other words, similar scores between them will be equal to 1, right? Because the fraction will be equal to 1 actually if C1 and C2 they are the same. However, for the real-world documents, if two documents are different, then this similarity score will be in the range from 0 to 1 state. Okay, so this is definition about this Jaccard similarity based on the sets. And we can define this metric in another way as well based on Boolean matrices instead. So, given the documents together with the shingle sets, we can represent their contents as a matrix or a Boolean matrix. What does this mean? And we can enumerate all the potential shingles contained by all the documents that sit in the sets as rows, right? So this row denotes the elements of the universal set. It covers all the shingles that may appear in all the documents. As to the columns of the matrix, it denotes different sets or different documents. Then what are other contents in the matrix? This matrix will be Boolean, right? If an element E appears in a document, if so, then we can type in this entry, the corresponding entry in the matrix with value 1. Otherwise, it will be 0. In other words, for this matrix, all the 1 values denote some element or some shingles appear in some sets or in some documents. Right. Okay, so based on this matrix, we can define the Jaccard similarity based on the column similarity matrix instead, which can be calculated in a very fast manner actually. So, when we are calculating the similarity score based on this equation, we may have to enumerate the contents or the elements in the sets, right? However, if we define the contents as a Boolean matrix, the calculation process will be much simpler actually. What does this mean? We can show you with a concrete example. So given two documents, we can convert them into two sets of shingles, and we can enumerate all the shingle contents by all the documents, right, as rows. This row denotes the universal shingle sets. We have A, B, C, D, E, F as shingles. And this column denotes different documents or their corresponding sets. We have C1 and C2, right? This matrix we mentioned before is binary. And the 1 values denoting the shingle appears in some documents. Now here we see this A appears in C2, right? This B appears in C1, C appears in both C1 and C2, and so forth. And then based on this kind of representation, how can we calculate this Jaccard similarity metric we defined before as C1 join C2 over C1 union C2? I always still remember in the previous pages when we talk about queries, we also provide you some description how to calculate the query results, right, based on the Boolean expressions. So given two documents C1 and C2, if we plan to find the common elements between them, and we have this appearance Boolean vectors, and this C1 join C2, actually the size actually equals to what? Equals to the summation of this vector and this vector. We can add these two vectors together, then we can sum all the values in them. Now this vector and this vector together will equal to what? This 0 and 1 will be equal to 0, right? 1 and 0 equal to 0. 1 and 1 equal to 1, right? 0 and 0 equal to 0. 1 and 1 equal to 1. And 0 and 1 equals to 0, right? So in other words, these two vectors added together will result in a vector with two entries containing 1, right? This entry as well as this entry. And sum of this vector of the result vector will be equal to 2 here, right? In other words, this join of two sets actually equals to the end between these two vectors. Similar here, if we want to calculate the union between these two sets, it can be defined or can be calculated by computing the OR between these two vectors, right? This vector OR, this vector will equals to 5 actually. Therefore, this Jaccard similarity between the two sets, we can do according to the definition, of course. If we decide to do based on the Boolean matrix, actually, it equals to what? Equals to this vector and this vector over this vector or this vector. In other words, it equals to 2 over 5, actually. It will be 0.4 here, right? So this is another way we can calculate based on the Boolean matrices instead, which will be much easier and more efficient actually. And I hope you can follow me and can also practice this example by yourself after class as well about how to calculate the Jaccard similarity scores.